Okay, section 11.3, perimeter and area of similar figures. If you think back to Geometry A, and even a little bit in Geometry B earlier on, we talked about similar figures. And when we talked about it, we talked about specifically a scale factor. So for instance, if I wanted to take figure A here, outlined in red, oops, I just erased that, outlined in red, and scale it up to B, my scale factor would be 3. By that I mean I would take every number 2, 3 in figure A and multiply it by 3. That would give me the 9, 6, and the 9 and the 6. Okay, in figure B. So real quick, the ratio of the perimeters of B to A, that will give me that scale factor. And let's watch what happens here. The perimeter of B is 30. And the perimeter of A is 10. That gives me 3. Alright, so the scale factor of the perimeters is 3. Now let's look at what happens to the scale factor of the ratios. Here, I want to take the area. Hold on a second. Sorry, guys. It's frustrating. Okay. Here I want to take the ratio of the areas of B to A. So this is B over A. Okay, and the ratio of the areas, well, the area of B is going to be 6 times 9, which is 54. And the area of A is going to be 2 times 3, which is 6. If we reduce that, that gives me 9. Okay, so what you notice, hopefully, is that the ratio of the perimeters is 3, but the ratio of the areas is 3 squared. Okay, and that's going to be incredibly important, and we'll use that idea throughout the entire section. Real quick, Theorems 11.7, areas of similar polygons. This is also really important. The side length of 1, so the side length of 1, divided by the side length of 2 of figure 2, so is going to be little a to little b. Okay. Now, the area of 1 over the area of 2, you can probably guess it, is not going to be just a over b. It's going to be a squared over little b squared. Okay? So that's kind of my rule of thumb when I have side lengths and area. We're going to use that to help us finish the chart down here in the next thing on your sheet. Okay? So, if I'm given the ratio of the corresponding sides, the corresponding side lengths and perimeters, those things are the same. The same. Okay, so ratio of the perimeters is going to be 5 to 8. Remember that we can write ratios as fractions or in kind of ratio form. So there's really no difference between 5 over 8 or, you know, A over B. Those are very similar. We could rewrite this as 5 over 8 and we'd be talking about the same thing, okay? But we'll leave that just as 5 to 8, ratio of 5 to 8. The ratio of the areas is going to be 5 squared to 8 squared, which is 25 to 64. Okay. 25 to 64. Let's look at the ratio of corresponding sides and perimeter in the next one. Remember, perimeter and sides are the same, so the ratio of the side lengths is going to be 4 to 7. The ratio of the areas is going to be 4 squared, 16, to 7 squared, which is 49. Okay. Now, let's look at going the other way. Here I've given you the ratio of the areas. Let's find the ratio of the perimeters. That's going to be the square root of 169. So 13, so we're going the other way. We're doing the opposite of squaring them. 13 to 6. And as usual, this is the same. and side lengths are the same, 13 to 6. Okay? And last, if you guys can see that bottom, there we go. If you guys can see the bottom one here, 66 is to 18. Well, let's first reduce that. What are we going to reduce that to, that 66 to 18? I think we can take maybe a 6 out of each one, and that'll reduce to 11 over 3, or 11 to 3. And that means that my ratio of the perimeter is going to be the same, 11 to 3. If I move all the way over to the right here, I'm going to square both of those, so my ratio of the areas is 121 to 9. Okay? And that's kind of the general rule of thumb that we'll kind of keep going back to that chart, the ideas in that chart, as I kind of bring up the next picture here. Okay. In fact, I want to even make that bigger than, give me more room here. Shoot. I guess that'll be okay. Alright, in this one, I want to find the ratio of the perimeters and areas. I want to find a bunch of stuff, really. Alright, so let's look at this first one. The first one, I want to find, this is my shaded. It doesn't really look shaded here, but this is shaded. Okay. And the first thing I want to find is find the ratios of the shaded to unshaded of the perimeters and areas. Okay? Cool. The first thing that I do in all of these is I make two columns. I make one that says this, ratio. Okay, this is frustrating. Ratio of perimeter then I have the same thing, the ratio of the area. Okay, I don't have room to write of, but ratio of the area. Okay, the ratio of the perimeter is going to be the same as the ratio of the side length. Alright, well, the ratio of the side length is going to be, well, let's see, let's think about this. I've got one side here and a corresponding side here. That's good. I know that this side is 1. We can talk about this in class, but I'll tell you that that side is 1 foot. The one that I'm missing that I've got to figure out here is this one. This side X here, that corresponding side. To do that, I'm going to set up a proportion to solve. Okay, so 2 is to 5 as 1 is to X, right? So we're following our kind of, we're going shaded to unshaded. 2 is to 5 as 1 is to X. To solve this, we cross multiply, which we should be pretty good at by now. 2 times X, 1 times 5. So 2X equals 5. Divide by 2, you get X equals 2.5. Okay, so X is 2.5. That means this side is 2.5, which means that the ratio of the perimeters is going to be 2 to 5. The ratio of the area, then, is going to be 4, well, 2 over 5 squared, so the ratio of the area, then, is going to be 4 over 25. Okay, it's the ratio of the area. So let's go through our directions, find the ratios of perimeters and areas. Good, good. And we want to find the unknown area. Well, I don't know the area of this second figure. Let's call this A, whoa, let's call this A2. Alright, I'm looking for A2, the area of the second figure, but I know the area of the first one is 2 feet. So let's set up a proportion to help me out here. Over here, I'm going to take A area of the first one, which is 2. And since I know that my scale factor is 2.5, oh, I'm sorry, back up. Excuse me, I apologize. Completely screwed this up. Not completely, but just the area, jeez. The area of A2 is just 2.5 times 5. Once I find that missing side length, I know that area 2 equals 2.5 times 5. Alright, which just gives me 12.5. Duh. Okay. So it is just 12.5, right? So length times width, 2.5 times 5. Okay. We'll probably do number 6 in class, or we'll do a warm-up that's similar. I would try that one, see how you do. You should get down to the area of that second one is 196 inches squared, but we'll probably do that one in class. So leave yourself some space. Let's go down to this last one, number 9 and 10 here. Number 9, I want to find the ratio of the lengths of the corresponding sides. So if I've got ratio of the areas, then the ratio of the sides is going to be the square root of both of those things. So it's going to be 4 to 9, very similar to what we did up above. Okay, same thing over here. If I've got the ratio of the areas, the ratio of the sides is going to be 5 to the square root of 196, which is 14. Okay, so tomorrow in class I'm going to give you a little bit more context with the warm-up as to what exactly I'm going to be wanting in the quiz. There's kind of a lot in this section to wrap your head around. I understand that. So like I said, tomorrow in class I'll try and give you a little bit more context as to where this will come up and how it will look on the quiz as far as problems on the quiz. So that's it for this section. We'll see you tomorrow in class.